He had such a powerful mind that when he looked into the void between spaces, he saw entire dimensions beyond the visible. Ireland, 1805. A boy reads, at the age of 10, books that many teachers would never dare to face. He's William Rowan Hamilton, and he's going to show us that the geometry of the world can expand, that there's another way of looking at rotations, that there's a new mathematical horizon where space and orientation intertwine. In this video, we'll reconstruct this universe step by step to the exact moment when Hamilton invented Quaternions, 4 numbers that changed everything. Stay until the end if you want to discover how this man transformed light, space, mathematical expression, and how his ideas still vibrate in the present. The Greatest Mathematicians of All Time, Episode 9, William Rowan Hamilton. Hamilton was born on August 4, 1805 in Dublin, Ireland, and died on September 2, 1865 in the same city. William Rowan Hamilton's father, Archibald Hamilton, did not have time to teach William, as he was often in England in pursuit of legal business. Archibald Hamilton had no university education, and it is believed that Hamilton's genius came from his mother, Sarah Hutton. By the age of 5, William had already learned Latin, Greek, and Hebrew. He learned these subjects from his uncle, the Reverend James Hamilton, with whom William lived in Trim for many years. James was a great teacher. William soon mastered other languages, and at the age of 8, he met the American Zerah Colburn. Colburn could perform incredible mental arithmetic feats, and Hamilton participated in arithmetic skill competitions with him. It seems that losing to Colburn sparked Hamilton's interest in mathematics. Hamilton's introduction to mathematics came at the age of 13, when he studied Clairaut's algebra, a task that became somewhat easier as Hamilton was fluent in French at this time. At age 15, he began to study the works of Newton and Laplace. In 1822, Hamilton found an error in Laplace's Mécanique Céleste, and as a result of this, came to the attention of John Brinkley, the Astronomer Royal of Ireland, who said, "This young man, I do not say that he will be, but he is the first mathematician of his time." Hamilton entered Trinity College, Dublin at the age of 18, and in his first year obtained an optime in classics, a distinction awarded only once in 20 years. In August 1824, Uncle James took Hamilton to Summerhill to meet the Disney family. It was at this moment that William met his daughter Catherine and immediately fell head over heels in love with her. Unfortunately, as he had 3 years left at Trinity College, Hamilton was not in a position to propose. However, Hamilton was making remarkable progress for an undergraduate and submitted his first paper to the Royal Irish Academy before the end of 1824, entitled On Caustics. The following February, Catherine's mother informed William that her daughter would marry a clergyman who was 15 years her senior. He was rich and could offer Catherine more than Hamilton. In his next series of examinations, William was given a bene instead of the usual valde bene due to the fact that he was so distraught about losing Catherine. He became ill and at one point even considered suicide. During this period, he turned to poetry, a habit he maintained for the rest of his life in moments of anguish. In 1826, Hamilton received an optime in science and classical studies, something unheard of, while in his final year of graduation he presented a memoir, Theory of Systems of Rays, to the Royal Irish Academy. It was in this paper that Hamilton introduced the characteristic function of optics. Hamilton's final examiner, Boyton,
persuaded him to apply for the post of Astronomer Royal at Dunsink Observatory, although there were already 6 applicants, one of whom was George Biddle Airy. Later, in 1827, the board appointed Hamilton Andrews Professor of Astronomy at Trinity College while he was still an undergraduate at the age of 21. The chair bore the honorary title of Astronomer Royal of Ireland and the benefit of residing at the Dunsink Observatory. This appointment generated much controversy, as Hamilton did not have much experience in observation. His predecessor, Professor Brinkley, who had become a bishop, did not consider the decision correct for Hamilton to accept the post and insinuated that it would have been prudent to wait for a scholarship. It turns out that Hamilton made a bad choice, as he lost interest in astronomy and began to devote all his time to mathematics. Prior to taking up this prestigious position, Hamilton traveled through England and Scotland. He met the poet Wordsworth, and they became friends. One of Hamilton's sisters, Eliza, also wrote poetry, and when Wordsworth came to Dunsink to visit her, it was her poems that he liked rather than Hamilton's. The two men had long debates about science versus poetry. Hamilton liked to compare the two, suggesting that mathematical language was as artistic as poetry. However, Wordsworth disagreed, saying that science applied only to the material uses of life waged war with the imagination and wished to extinguish it. Wordsworth had to tell Hamilton quite vehemently that his talents lay in science rather than poetry. "You send me showers of verses that I receive with great pleasure, but we fear that this occupation may lure you away from the path of science. Again, I venture to submit to your consideration whether the poetical parts of your nature would find a field more favorable to your nature in the regions of prose, not because these regions are more humble, but because they can be trodden with grace and profit, with less careful and, to a certain extent, more elaborate steps."
Hamilton accepted a student named Adair. They were a bad influence on each other, as Adair's eyesight began to show problems as he was watching too much, while at the same time Hamilton fell ill due to overwork. They decided to take a trip to Armagh for a vacation and to visit another astronomer, Romney Robinson. It was on this occasion that Hamilton met Lady Campbell, who would become one of his favorite confidants. William also took the opportunity to visit Catherine, as she lived relatively close by, which she then reciprocated by going to the observatory. Hamilton was so nervous in her presence that he broke the telescope's eyepiece while trying to give her a demonstration. This episode inspired another interval of misery and poem writing. In July 1830, Hamilton and his sister Eliza visited Wordsworth, and it was at this time that he began to think seriously about getting married. He considered Ellen de Vere and told Wordsworth that he, quote, admired his mind, but he did not mention love. He did, however, bombard her with poetry and was about to propose when she said she could, quote, not living happily anywhere else but Curra. Hamilton thought this was her way of tactfully discouraging him, so he stopped chasing her. However, he was proven mistaken, as she married the following year and left Curra. Fortunately, one bright spot transpired from the event. Hamilton became close friends with Ellen's brother, Aubrey, although a dispute over religion in 1851 led them to go their separate ways. Catherine aside, Hamilton seemed rather fickle about relationships with women. Perhaps this was due to the fact that he thought he should get married, and so, if he couldn't have Catherine, it didn't matter who he married. In the end, he married Helen Maria Bailey, who lived across the fields from the observatory. William told Aubrey that she was, quote, not brilliant at all, and unfortunately the marriage was doomed to fail from the start.
They spent their honeymoon at Bailey Farm, and Hamilton worked on his third supplement to his theory of ray systems throughout the period. At the observatory, Helen had little idea of household chores and was so often ill that the house became extremely disorganized. In the following years, she spent most of her time away from the observatory, caring for her sick or indisposed mother. In 1832, Hamilton published his third supplement to the theory of ray systems, which is essentially a treatise on characteristic function applied to optics. Near the end of the work, he applied the characteristic function to study the Fresnel wave surface. From this, he predicted conic refraction and asked Trinity College physics professor Humphrey Lloyd to try to verify his theoretical prediction experimentally. This Lloyd did 2 months later, and this theoretical prediction brought Hamilton great fame. However, it also led to controversy with McCulloch, who came very close to theoretical discovery, but he was forced to admit failed to take the last step. On 4 November 1833, Hamilton read a paper to the Royal Irish Academy expressing complex numbers as algebraic pairs or ordered pairs of real numbers. He used algebra in the treatment of dynamics in On a General Method in Dynamics in 1834. In this paper, Hamilton presented his first statement of the characteristic function applied to dynamics and wrote a second paper on the topic the following year. Hankins writes, "These articles are difficult to read. Hamilton presented his arguments with great economy, as usual, and his approach was entirely different from that commonly presented in textbooks describing the method. In the 2 essays on dynamics, Hamilton applied the characteristic function to dynamics for the first time, as he did in optics, the characteristic function being the action of the system as it moves from its starting point to its end point in the configuration space. By means of his law of variable action, he made the initial and final coordinates the variables independent of the characteristic function. For conservative systems, the total energy was constant along any real path, but varied if the start and end points were varied, and so the characteristic function in dynamics became a function of the coordinates of the start and end position for particles and the Hamiltonian."
The year 1834 was the year in which Hamilton and Helen had a son, William Edwin. Helen then left Dunsink for 9 months, leaving Hamilton to struggle with loneliness, devoting herself even more to her work. In 1835, Hamilton published Algebra as the Science of Pure Time, which was inspired by his study of Kant and presented at a meeting of the British Association for the Advancement of Science. This second paper on algebraic couples identified them with steps in time, and he referred to the couples as time steps. Hamilton was knighted in 1835, and that year his second son, Archibald Henry, was born, but the following years did not bring him much happiness. After the discovery of algebraic couples, he tried to extend the theory to triplets, and this became an obsession that plagued him for many years. The following autumn, he went to Bristol for a meeting of the British Association, and Helen took the children with her to Bailey Farm for 10 months. Her cousin Arthur died, and shortly after Helen returned from her mother's home, she left again for England, this time leaving her children behind after the birth of a daughter, Helen Eliza Amelia. At this point, William became depressed and began to have problems with alcohol, so his sister returned to live in Dunsink. Helen returned in 1842 when Hamilton was so worried about the triplets that even her children noticed. Every morning they ask, "Well, Dad, can you multiply triplets?" But he had to admit that he could still only add and subtract. On 16 October 1843, a Monday, Hamilton walked across the Royal Channel with his wife to chair a meeting of the Council of the Royal Irish Academy. Although his wife spoke to him from time to time, Hamilton barely listened, as the discovery of Quaternions, the first non-commutative algebra to be studied, was taking shape in his mind. And here the notion occurred to me that we must admit in some sense a fourth dimension of space for the purposes of calculations with triples. An electrical circuit seemed to close and a spark flashed. He couldn't resist the urge to carve the formulas for Quaternions on the stone of Broom Bridge, or Brougham Bridge as he called it, as he and his wife passed through it.
In 1958, the Royal Irish Academy erected a commemorative plaque. Hamilton felt that this discovery would revolutionize mathematical physics, and he spent the rest of his life working on quaternions. He wrote, "I must still state that this discovery seems to me as important for the middle of the 19th century as the discovery of Fluxions calculus was for the end of the 17th century." Shortly after Hamilton's discovery of quaternions, his personal life began to haunt him again. In 1845, Thomas Disney visited Hamilton at the observatory and brought Catherine with him. This must have upset William, as his dependence on alcohol worsened. At a meeting of the Geological Society the following February, he exhibited himself because of his intoxication. Macfarlane writes, "At a dinner of a scientific society in Dublin, he lost control and was so mortified that on the advice of friends he resolved to abstain altogether. He kept this resolution for 2 years, when was brought about by limiting himself to water, mainly by airy. He broke his good resolve, and from that moment on, the desire for alcoholic stimulants haunted him." The year 1847 brought the deaths of his uncles James and Willie, and the suicide of his colleague at Trinity College, James McCullough, which greatly disturbed him, although they did not always understand each other. The following year, Catherine began writing to Hamilton, which must not have helped in this time of depression. The correspondence continued for 6 weeks and became more informal and personal until Catherine felt so guilty that she confessed to her husband. Hamilton wrote to Barlow and informed him that they would never hear from him again. However, Catherine wrote once again, and this time attempted suicide, unsuccessfully, as her remorse was too great. She then spent the rest of her life living with her mother or siblings, although there was no official separation from Barlow. Hamilton persisted in his correspondence with Catherine, which he sent through his relatives. It's no surprise that Hamilton gave in to alcohol immediately after that, but he threw himself into his work and began writing his lectures on quaternions. He published Lectures on Quaternions in 1853, but soon realized that it was not a good book for learning the theory of quaternions. Perhaps Hamilton's lack of skill as a teacher manifested itself in this work. Hamilton helped Catherine's son, James, prepare for his specialization exams, which were about quaternions. He saw this as revenge against Barlow, as he was able to help his son in a way that his father could not. Later that year, Hamilton received a case from Catherine with an inscription that read, "Of someone you should never forget, nor think badly of her, and who would have died happier if we had met again." Hamilton went straight to Catherine and gave her a copy of Lectures on Quaternions. She died 2 weeks later. As a way of coping with his grief, Hamilton tormented the Disney family with incessant correspondence, sometimes writing 2 letters a day. Lady Campbell was another sufferer of the burden of correspondence, as only she and the Disneys knew of her love for Catherine. On the other hand, Helen must have always suspected that she did not hold the top spot in her husband's heart, a notion that must have been strengthened in 1855 when she found a letter from Dora Disney, Catherine's sister-in-law. This led to an argument, although the only consequence was that Dora had her letters addressed by her husband. They did not stop completely. Determined to produce a body of lasting quality, Hamilton began writing another book, Elements of Quaternions, which he estimated would be 400 pages long and take 2 years to write. The title suggests that Hamilton modeled his work on Euclid's Elements, and indeed this was the case. The book ended up doubling the intended length and took 7 years to write. In fact, the final chapter was incomplete when he died, and the book was finally published with a foreword by his son, William Edwin Hamilton. Not everyone found in Hamilton's Quaternions the answer to everything they were looking for. Thomson wrote, "The Quaternions sprang from Hamilton after his excellent work was done, and while they are wonderfully ingenious, they have been an absolute evil to those who have touched them in any way." Cayley compared Quaternions to a pocket map.
that contained everything but needed to be unfolded into another form before it could be understood. Hamilton died from a severe gout attack shortly after receiving news that he had been elected the first foreign member of the U.S. National Academy of Sciences.
Hamilton looked beyond the horizon of his time. He crossed barriers that many considered unattainable: mathematical challenges, academic expectations, his own health. He left us more than formulas. He left a new way of seeing space, of seeing transformations, of seeing beauty hidden in rigor. Whenever you use vectors, 3D rotations, computer graphics, quantum physics, somehow you're living Hamilton's legacy. If today mathematics seems cold or distant to you, remember, there are stories like Hamilton's that show that each equation has a heart, each discovery a soul. If you liked this epic dive into Hamilton's life, leave the like. It helps a lot. Share this video with someone who also loves science or math, and sign up so you don't miss the next profiles of extraordinary minds that we will bring here. See you in the next video. Until then, keep your curiosity sharp, and may your ideas be as audacious as the ones that changed the world.